Hi, my name is Steve Blyle, and I'm a welder. From fabrication and repair shops to backyard garages, arc welding is one of the most common and versatile methods of joining metal. The arc welding process. Electric current from a welding machine produces an arc between the base metal and a consumable electrode, which is the welding rod. That arc burns the flux coating on the rod, creating gases that shield the weld area from coming in contact with oxygen in the air. The gases surrounding the arc are superheated, causing the base metal to melt, while the filler metal from the rod is being deposited into the molten puddle. Whether you're learning to weld to build something or make repairs, the first step is to learn how to consistently run a good weld bead. Before we start burning rod, though, there are a few things you should know about the equipment we'll be using. So let's begin with the welding machines. The job of a welding machine is fairly simple, and that is to provide a steady, controllable current to the electrode. Now, regardless of the size or shape, welding machines will provide either alternating current or direct current to the electrode. And this little machine gives you the choice of either AC or DC. The main advantage of alternating current is that it's easier to produce. They use simple transformers, so you generally get more power for your money. This one will give you 225 amps on AC, but only 150 amps on DC. If you think about alternating current, the electrons are moving back and forth, and at the point where the electrons change direction, the flow or current actually stops. Certain welding rods have been designed with stabilizers in the flux to help maintain and control the arc through these amperage lags. So if you're using a welding machine that provides alternating current to the electrode, you want to make sure to use a welding rod designed for alternating current. Most welding shops and professional welders use machines that provide direct current to the electrode. And in my shop, I use a 250 amp DC machine. Direct current provides a steady flow of electrons in one direction. The polarity, or direction of flow, is determined by how the leads are connected to the positive and negative terminals on the welding machine. And many of the newer welding machines have a switch to choose the polarity. DC EP, or DC plus, is direct current electrode positive. The electrode is connected to the positive and the ground is connected to the negative terminal. Current is generally considered to flow from negative to positive, so with the electrode positive, the arc actually travels from the metal up to the welding rod. This causes the tip of the rod to superheat. For general purpose welding, all the common welding rods use DC EP with the electrode positive. DC EN, or DC minus, is direct current electrode negative. The electrode is connected to the negative terminal and the ground is connected to the positive. With DC EN, the flow is from the welding rod to the metal, so the rod stays cooler and the metal gets the heat. This is used with certain rods for high-speed sheet metal welding. When you're starting out, you'll probably be welding with a machine that's put in front of you. And basically, if it's in proper working condition, you can weld with it. Keep in mind, though, that welding machines will weld differently. Even two identical machines may not operate quite the same. So while you're learning to weld, try to use the same machine as much as possible. Welding leads are insulated copper wire and come in sizes like a number 4, 2, 1, and single-aught. The larger the number, the smaller the diameter. The size welding lead you need to use depends on how many amps you'll be using and how long the lead is. And welding supply stores have charts to determine the size lead you need to use. On the end of the main lead, I use a quick connect with about 15 feet of number 4 lead and the electrode holder. This is called a whip. The smaller lead is a little more flexible and easier to deal with. This is a 200 amp electrode holder. Larger ones like 250 or 300 amp are available if you're mainly using big rods with high amperage settings. But for general use, the 200 amp is more comfortable. And I usually call this the stinger. Another type of electrode holder is available where you stick the rod in and twist the handle. If you need the rod at a different angle, you can just bend it. You also need a ground clamp. And I use a quick connect here too, in case I need to add more lead. Now, the light from arc welding is extremely bright. You need filter lenses to see the molten weld puddle and to protect your eyes from getting burned. These are typically available from a number 8 to a number 14. The lower the number, the lighter the lens. From what I can tell, some people are more sensitive to this light than others. A number 8 filter lens is way too light. Industry recommends a number 10, and I use a number 9. The lens has to be dark enough to protect your eyes, but light enough so you can clearly see the weld puddle. If you're welding with big rods using high amperage, you may want a shade darker lens than normal. And if this filter lens gets chipped or cracked, replace it. To protect the filter lens from sparks or getting scratched, I use clear plastic lenses in front and in back. There's a gasket that goes in first to seal the lenses, and everything's held in place with a clip. After you install the lenses, hold the hood up to a light and check for leaks around the edges. When you start welding, check it again. If any light from the arc is leaking around the edges of the lenses, it'll burn your eyes for sure. Also, replace the clear lenses when they get dirty or scratched. Having a clean lens makes a big difference in allowing you to clearly see the weld puddle. Okay, the last thing we need are welding rods. So let's take a look at some of the common ones. Some of the more common welding rods for carbon steel are E6010, 6011, 6013, and 7018. And the numbers are written right on the rods. These numbers actually mean something, so let's take a look at E6010. The E designates an arc welding electrode. The first two numbers, in this case 60, indicate that the filler metal has a tensile strength of 60,000 pounds per square inch. Depending on certain conditions of the weld, you may get a little more or less, but it'll be close to that. The 70 and 7018 indicate 70,000 pounds per square inch. So the first two numbers indicate tensile strength, and tensile strength is the force it takes to pull it apart. The third number indicates the position the rod can be used in. A number 1 shows that the weld puddle solidifies quick enough so this rod can be used in any position, flat, vertical, horizontal, or overhead. A number 2, like in 7024, indicates that the molten puddle remains so fluid this rod can only be used in the flat position or for a horizontal fillet, which is more or less flat. The last two numbers together, here it's a 10, indicate the composition of the flux coating. And this flux is what makes the whole arc welding process possible. As it burns, a gas is created that purges the weld puddle, keeping the oxygen in the air from mixing with the molten metal, which could cause gas pockets in the weld bead called porosity. The flux also helps stabilize the arc, and it lifts impurities from the molten metal. When the flux cools, it forms a slag coating over the hot weld bead, providing more protection from the air. There isn't a magic welding rod that just does everything. You may find one that you like to use and that produces good results, but basically welding rods can be put into one of two groups, fast freeze or filler. The fast freeze rods, 6010 and 6011, have a strong arc force that provides deep penetration. A light flux coating makes the molten weld puddle clearly visible, and the weld puddle solidifies relatively quick, leaving distinct ripples in the finished weld bead. Filler rods, 6013, 7018, and 7024, don't penetrate as deep. They build up weld bead. A heavier flux coating covers the weld puddle, keeping it more fluid, allowing for a smoother finished weld bead. So where exactly do you use these different welding rods? 6010 is used strictly on DC plus and 6011 on AC or DC plus. The strong arc force of these rods can blow off rust and paint, making these a good choice for repairs or modifications where the metal can't be completely cleaned. Also, these rods are often used as a first pass, to provide deep penetration or to fill gaps and fit-ups that are less than perfect, then covered with a filler rod. 6013 was actually designed for high-speed sheet metal welding on DC-, but these rods can also be used on AC or DC+ for general purpose welding and light fabrication. With stabilizers in the flux, 6013 is probably the easiest of all the rods to use, and it produces a smooth finished weld bead. 7018 is a low hydrogen rod with iron powder in the flux. It's generally used on DC+, and an AC 7018 is also available. These produce the highest quality welds and were developed for situations where there's extreme stress on the weld joint. It can be used to weld some of the harder low alloy steels on cast steels, and when making heavier welds, the low hydrogen characteristics prevent the weld from cracking because of the expansion and contraction of the metal. Iron powder in the flux provides a high filler metal deposit rate, which means you can put more metal down faster. 7018 produces a smooth finished weld bead, but does require clean metal and a well-prepared joint. 7024 was used extensively in fabrication before wire feed. A heavy flux coating produces an extremely smooth weld bead, but these rods do require clean metal and a slightly higher amperage setting. 7024 can be used on DC+ or AC, and the 2 does indicate that this rod can only be used in the flat position. 6010, 6011, 6013, and 7018 are common rods and should be available everywhere. There are other welding rods, and they'll either be a fast freeze or a filler, with a different tensile strength, a slightly different flux covering, and usually designed for a specific purpose. Now, each of these rods has distinct characteristics, but there are some basic fundamentals that are common to all of arc welding. We'll start with the fast freeze type rods, because the light flux allows you to see the molten weld puddle clearly. The fast freeze rods 6010 and 6011 are similar, and the same techniques can be used with either one. 6010 on DC+ might freeze or solidify a little quicker. 6011 with either AC or DC+ may be a little easier to use because of the stabilizers in the flux that help maintain the arc. Let's start by watching a weld, and I'll try and describe what to look for. After scratching the rod against the metal to make contact, the tip is held about 1/8 of an inch or 3 millimeters off the surface. This creates a gap for the arc to cross, and that's where the bright light comes from. While you're welding, don't watch the light. Look past it, through the smoke and sparks, and focus on the molten puddle of metal behind the rod. Welding takes a little practice, but it's not very difficult. Let's go through this step by step. First of all, you need to pay attention. This is ready to go. Anytime the tip of the rod touches the metal, it will arc. Okay, you want to get comfortable. Welding rods burn for about a minute, and it's a long ways out to the tip of the rod. So get comfortable and relax. Rest your arm on the table and use both hands on the stinger so you can be as steady as possible. When you're all set, either reach up and flip your hood down, or you can adjust the knobs on the side to flip the hood down with a nod. Starting the arc is like lighting a match. Drag the rod right against the metal. When it lights, bring the tip up and move back to the start. A scratch start gets the flux burning, forming the gases that purge air away from the molten puddle. To avoid leaving arc burns all over the metal, try to scratch right where you intend to weld. I usually hold the stinger with my thumb on the release lever. If the rod ever sticks, just open the stinger, then go back and break the rod off. If you're relighting a rod, the flux may be broken off a little at the tip. A scratch start will burn off that tip before you start depositing metal. Once the rod is burning, you need to start the puddle, giving the molten filler metal a little extra time to fuse to the base metal. This doesn't take long, only 2 or 3 little circles. Also, as the weld progresses, the base metal will heat up, causing the molten puddle to spread out. Start the puddle wide enough to keep the weld bead a uniform width. During the weld, the tip of the rod is held up off the metal. This is called the arc gap. Having control of this arc gap is one of the first and may be the most important thing you need to learn. As you're moving along to build weld bead, the rod is being consumed, so you also have to be moving in. And the whole time you need to maintain a constant, uniform gap between the tip of the rod and the base metal. If the tip of the rod is jammed right down on the metal, the arc doesn't have time to heat up the base metal. The weld bead kind of squirts out the back, not tying in well on the sides. If the arc gap is too long, the arc itself can jump around. Penetration will vary and you lose control of how the filler metal is deposited. Maintaining a constant arc gap is the first step to controlling the molten puddle and producing a uniform weld bead with consistent penetration. The better you learn to control that arc gap, the better you'll be able to weld. When the arc crosses the gap, it melts the base metal, forming a molten puddle. That arc stream also carries the filler metal from the rod into the puddle. This is a 60-10 weld bead that I pulled out of quickly. The leading edge of the puddle was actually below the surface of the metal. The strong arc force of 60-10 and 60-11 penetrates deep into the base metal and pushes the molten puddle back, building up weld bead. While you're welding, watch the sides, right where the weld buildup meets the surface of the base metal. For building up weld bead, either a circular or zigzag motion is commonly used. With a circular motion, as you ease the puddle over, watch the edge. When you bring it across, watch the weld build up, then the other side, and just ease the puddle around and around. A side-to-side or zigzag will produce nearly the same weld bead. Watch the outside edge, the weld build up, and the outside edge every time you cross. Something you want to keep in mind is that molten metal will follow the heat. Whenever you move the puddle across, while you are adding filler metal from the rod, molten metal is also following from the side. If enough metal isn't put back there when you come around again, you'll leave undercut. Undercut is a void or groove along the edge of the weld bead that's below the surface of the base metal. You can avoid this by always watching the outside edges to make sure the puddle is filling in and tying in at the surface. There's an arc force at the end of this rod that we can use to help manipulate the weld puddle by angling the rod. Think of it more like pushing the puddle instead of dragging it. Generally speaking, the straighter up and down you hold the rod, the less weld buildup. As you angle the rod, the more the weld bead will stack up. When the rod is held straight up and down, all the heat is concentrated right under the rod, and the arc force drives the puddle down. This results in deep penetration and spreads the puddle out for a flatter weld bead. As the rod is angled, the arc force is directed more to the back of the puddle, allowing the weld to build up. If the rod is angled too low, the arc is directed right where you're trying to build weld, making the puddle hard to control. You will run into situations where you may want to flatten out the weld, or you'll need to push the puddle back more, so you'll use different rod angles. When you're starting out, an angle somewhere between 45 degrees and straight up and down is comfortable, allows a good view of the puddle, and works well for building weld bead. The rod size is the diameter measurement of the metal in the electrode. Common sizes are 332, 1/8, and 532. Most welding rod size charts, where they give the metal thickness to the rod size and amperage setting, are generally from the point of view of maximum weld in minimum amount of time, often not taking into account the welder's ability or different welding situations. You can always use a smaller diameter rod for better control. It just takes a little longer to build up weld bead. This is a 1/8 E6010 electrode, and this is the most common size used. The manufacturer's recommended amperage setting is from 75 to 130 amps. They're saying this rod will work over a 55 amp range. The specific amperage setting is considered a variable and depends on metal thickness, position of the weld, and the welder's ability. The whole purpose in arc welding is to get the base metals hot enough to melt, forming a molten puddle. If the amperage is set too low, the base metal doesn't get hot enough, and the puddle looks like it's following the rod around. If the amperage is set too high, the base metal gets too hot. The stronger arc force gouges deep into the base metal and pushes the puddle back. When the amperage is set about right, the puddle will spread out and the outside edges tie in immediately. You can ease the puddle around, kind of pushing it with the movement of the rod. Depending on each welding situation, the amperage setting can change. Thicker metal dissipates the heat, so you need a little more amperage. Thinner metal will get hot fast, so you can use a little lower amperage. The final amperage setting is determined by what the molten puddle is doing. You do need a place to start, so try about the middle of the manufacturer's recommended range, and don't be afraid to go up or down a little bit. Welding really is about the temperature of the base metal, so we can't talk about the amperage setting without looking at the speed of progression, or travel speed. The faster you move, the less time heat is put to the base metal, so it stays cooler. When you move slower, you're putting the heat to it for a longer amount of time, so the base metal gets hotter. When you move too fast, the metal doesn't have time to heat up, so the weld bead just skates across, not getting any penetration. If you move too slow, the metal gets extremely hot, causing the puddle to spread out, making it hard to control. When the travel speed and amperage setting match, the puddle spreads out, but it's still controllable. The sides tie in and the weld builds uniformly. As you gain more control of the rod, try using a slightly higher amperage setting and increasing the speed of travel. The higher amperage setting provides better penetration and a smoother finished weld bead. Try to weld as hot as you can control the molten puddle. To finish a weld bead, add a little extra metal before you pull out, to avoid leaving a crater that's below flush with the surface of the base metal. Circle the rod once or twice, then bring the rod up and back over the weld. While different rods may not look quite the same, these are the basic steps for all the welding rods. Scratch to get the arc going. Start the puddle wide enough to keep the weld a uniform width. Maintain a uniform arc gap with an amperage setting high enough to let the puddle spread out. Ease the puddle around using the force of the arc and watch the sides and the weld build up. Add some filler metal before pulling out over the weld bead. That's about all there is to it. For 60-10 in the flat position, try a circular motion and angle the rod to build up weld. Watch the molten puddle, not the light. Keep the circles tight for a smoother weld bead. A zigzag motion will produce about the same weld. Watch the edges to make sure they're filling in and ease the puddle back and forth. Because of the strong arc force and light slag, you can also use a whip or step motion, and this is what makes the fast freeze rod so versatile. The tip of the rod is moved back so the arc is actually brought out of the puddle. Then molten metal is pushed back in. With the step motion, watch both sides and the weld build up every time you push the puddle in. This kind of rod movement can be used for deep penetration by digging down on the backstroke, then filling the gouge in. On thinner metals, where you don't need a lot of penetration, you can puddle, then long arc to let the weld bead cool, and puddle again. The thinner the metal, the faster this goes. The step motion can also be used to fill gaps in poorly fit joints. Keep the rod deep in the gap and bring it back, allowing the metal to cool. Then push a little more metal in to fill the gap and let it cool again. The step motion may not always look real slick, but it's usually covered with another pass. So far, we've been welding in the flat position. For a vertical with 6010, you can run either uphill or downhill. Downhill is easier, but there's less penetration and weld buildup. Because heat rises, you're welding away from the heated metal, so you can use a slightly higher amperage setting. Watch the sides and the weld buildup. Try a circular, zigzag, or step motion and angle the rod up a little so the force of the arc helps hold the puddle up. With a circular motion, keep a steady arc gap and ease the puddle around. Move fast enough to stay ahead of the molten puddle. If the puddle wants to drip down, try moving faster, or maybe even a slightly higher amperage setting. When you weld uphill, you'll be welding into the heated metal, so turn the amperage down a little. Angle the rod up so the force of the arc doesn't blow the puddle out. An uphill weld really gouges into the base metal, making undercutting a potential problem. So pay particular attention to the sides of the puddle and watch the weld buildup underneath the rod. If the base metal gets too hot, the puddle may fall out, or you might burn a hole right through the metal. Mess with the amperage setting and your travel speed until you can carry that puddle right uphill. A horizontal weld is a cross, and you want to angle the rod to push the puddle up. Keep the rod nearly perpendicular to the metal or angle into the weld a little bit. If you angle the rod too far, the arc force can blow the puddle out. Using a circular motion, keep a steady arc gap and just ease the puddle around. Every time you bring the rod down, the molten metal will follow the heat. Make sure you push the puddle up and watch the top side. If the bead is wanting to sag down, try a faster travel speed to keep the base metal cooler. That leaves us with overhead, straight up and down. Overhead is about the same as welding flat, just a little more awkward. The real challenge is to find a comfortable position so you can keep the rod steady. Your welding hood should have an adjuster to help hold it up, so you don't have to bend your neck back so far. Now, believe it or not, the molten puddle doesn't want to fall out. Unless you blow it out with the arc force, the molten metal wants to stay with the heat. It likes the heat. Hold the rod nearly straight up and down or angled slightly in the direction of travel, away from the weld. Try a circular motion and just make the puddle look the same as when you're welding flat. All the sparks will be coming your way, so wear protective clothing like a leather coat, some good gloves, and I like to cover my ear with a hat. Getting burned is a little distracting when you're trying to run a good weld bead. 6010 and 6011 won't give you a smooth finished weld bead, but they do provide deep penetration in weld joints and when making repairs. 6013 welding rods were developed for welding sheet metal on DC-. The rod is held perpendicular to the metal with a tight arc, and the travel speed is as fast as you can go without having the weld bead skip. Today, 6013 is more often used for general purpose welding with AC or DC plus, and it is a good rod for the small, low amperage welding machines. One of the first things you'll notice about 6013 is that there's a heavier slag coating on the weld bead. The slag even covers the top edge of the weld puddle. This keeps the puddle more fluid, helping to produce a smoother, finished weld bead. Typically, 6013 is available in 332, 1/8, and 532. 1/8 is the most common size used, and try starting with an amperage setting around 130 amps on AC or 115 amps on DC. Because of the slag covering, the differences in the appearance of the weld are a little more subtle, but when the amperage is set too low for the situation, the puddle will follow the rod around, taking longer to tie in on the sides. The heavier slag may even interfere with the arc. If the amperage is set too high, the molten puddle and slag are extremely agitated and remain molten longer. When the amperage is about right, the weld puddle spreads out, tying in and moving easily with the motion of the rod. In the flat position, you can run straight or try a little side-to-side motion. Angle the rod somewhere between 45 and 90 degrees to build up weld bead. Scratch start the puddle, and maintain a short arc gap, even to the point of lightly resting the tip of the rod on the metal. Watch the puddle. The slag covers the top edge, but you can still get an idea of the weld buildup. Watch the sides to keep the weld bead straight, and just ease the puddle side to side. On vertical welds, 6013 was designed for a downhill application. You'll be welding away from the heat, so try turning the amperage up 5 to 10 amps. Angle the rod up so the force of the arc helps hold the puddle up. Maintain a short arc gap and try a slight side-to-side movement. Watch the outside edges to keep the weld bead straight and travel fast enough to stay ahead of the molten puddle. If you can't stay ahead of the molten puddle coming down, try moving a little faster or raising the amperage setting. For more weld buildup on heavier metal, 6013 can be run uphill. Start by turning the amperage down 5 to 10 amps. Try using a side-to-side motion, moving up fast enough to keep the puddle from dripping down. Make sure the sides are filling in to avoid leaving undercut. To make a horizontal weld, angle the rod up to help push the puddle up. Keep the rod nearly perpendicular to the metal or angled back into the weld just a little. Maintain a short arc gap and constant travel speed to produce a smooth weld bead. The molten slag will run down, covering the bottom, but watch the top side of the puddle. Move fast enough to avoid excessive weld buildup. While you're learning to weld horizontally, don't try to carry too much metal. Keep the weld bead small. If you need more weld, you can always run a second pass above the first one. Overhead with 6013, like every other type of welding rod, is awkward. Hold the rod straight up, or, because of the mild arc force, you can angle it back into the weld a little bit, and try a slight circular motion. The heat of the weld is going straight up, right where you want it. So if you can get in position to maintain a short arc gap and uniform travel speed, overhead will produce a good weld. 6013 is the favorite rod in many home shops. They're easy to light, they maintain the arc, and produce a good-looking finished weld bead. 7018 produces an extremely high-quality, good-looking weld bead. This is the rod to use for heavier fabrication and repair or any situation where there's stress on the weld joint. These rods rely on a heavy slag coating to protect the molten weld puddle from coming in contact with oxygen in the air. This heavy slag makes 7018 run a little different than the other rods we've looked at. With the fast freeze rods, 6010 and 6011, the molten metal in the weld puddle is completely visible. Slag covers the top edge of the molten puddle with 6013, but the filler metal and slag solidify pretty much at the same time. With 7018, the entire weld puddle is covered by molten slag. The filler metal actually solidifies underneath, while the slag stays molten on top. If you keep in mind that what you see is molten slag and understand what the metal is doing underneath, 7018 is fairly simple to use. And even though the metal is solidifying underneath, watching the molten slag behind the rod will give you an idea of the weld buildup. 7018 is a little more sensitive to arc gap and rod movement. Make sure you're comfortable so you can be as steady as possible. A scratch start will get the flux burning before you deposit any metal. If you're relighting a rod, there's usually slag covering the tip. You may have to bump the rod to break that slag, then scratch to get going. Once the rod is lit, start the puddle. Besides tying in and getting started wide enough, This gives a little extra time for the gases to cook out of the molten puddle. If you move too quick, gas pockets may cause voids in the weld bead called porosity. Most times they're not even visible until you grind into the weld bead. Porosity can also be caused by welding on metal that's rusted, painted, or has any contaminants on it like oil or grease. 7018 does require clean metal. After the puddle is started, try a little side-to-side motion, maintaining a constant short arc gap. In some situations, you can even lightly rest the rod on the metal. With a mild arc force and slag covering the puddle, you do want to avoid letting the rod burn up or pulling the rod away from the metal. You don't want to let that slag cool, so keep the arc in the puddle. The typical rod sizes are 332, 1/8, and 532. Because the flux contains iron powder, which deposits more metal in the weld puddle, 7018 requires a little higher amperage, and these settings may vary up or down depending on metal thickness, weld position, and your ability to control the movement of the rod. With molten slag covering the entire puddle, you depend more on how the puddle acts than how the puddle looks. If the amperage is set too low for the conditions, the puddle won't spread out, taking longer to tie in on the sides. The rod might stick or go out. If the amperage is set too high, the puddle is agitated and extremely fluid. Little balls of metal might dance off to the sides, causing excessive weld spatter. When the amperage is about right, the slag solidifies back from the rod. The sides tie in and you can ease the puddle side to side. Here again, as you gain control of the arc gap, rod movement, and travel speed, you'll find that 7018 runs easier and cleaner with the amperage set a little to the hot side. The angle of the rod not only affects how the filler metal is deposited, but how the molten slag will behave. If the rod is held straight up and down, the slag can get in front of the weld puddle. If the rod is laid too far down, the flux coating won't burn evenly and the rod may stick. When the rod is angled between 45 and 90 degrees, the slag is forced back where it belongs, over the molten filler metal. Welding in the flat position is fairly simple. Remember to relax, get comfortable, and use 2 hands on the stinger. Try to maintain a short arc gap and constant travel speed. Watch the outside edges of the puddle to make sure they're fusing and staying even. Look behind the rod for an idea of the weld buildup. In the flat position, even 532 rods are fairly easy to control if your welding machine can produce enough amperage and there's plenty of metal to carry the heat. For a horizontal, we'll be welding across. If you're just starting out, try using a 332 rod. The smaller puddle is a little easier to control. Normally, I weld from left to right because I can see the puddle better. For 7018 in a horizontal, I move from right to left. You can weld in either direction, whichever is more comfortable. Angle the rod up and back into the weld a little. The puddle is fluid, so keep moving to avoid excessive weld buildup. Molten slag will cover the bottom, but watch the top side to keep the bead straight and avoid undercut. If the weld bead wants to sag, try increasing the travel speed. You want to go slow enough to let the molten metal fuse, but fast enough to keep the base metal from overheating, which causes the puddle to get more fluid and sag. Vertical welds with 7018 are made uphill. Start at the top and scratch down to where you want to start the puddle. You can run straight up or use a side-to-side movement. When I do this, it feels like there's a slight arc in the motion. Move across the center relatively quick. As soon as the puddle ties in on the side, cross back and keep on going. The amperage setting and travel speed go hand in hand, especially when you're going uphill. Maintain a constant short arc gap. Don't let the rod burn away and don't jam the rod into the puddle. As you gain experience, you can carry more metal. but try starting out with a 332 rod and keep moving. You don't want the base metal overheating, which is the main reason the puddle falls out. Overhead with 7018 produces an excellent weld. The heat is going right where you want it. Try about the same amperage you'd use for welding flat and hold the rod nearly straight up and down or angled slightly into the weld. You can run straight or try a little side-to-side motion to carry more metal, and you can carry quite a bit of metal overhead. Get comfortable and be creative if you have to. When you can control the rod movement, that metal will stay up there. However, because the slag remains molten longer, the slag can drip. I usually wear a leather welding jacket for overheads. You will be right underneath the weld. 7018 takes a little more practice, but it's well worth the time to learn how to use this rod. Well, that's about it. I hope I've given you an idea of what to do and what to look for to run good weld beads. As you're welding, concentrate the whole time you're burning that rod and focus on the molten puddle. Do whatever it takes to make that puddle do what you want it to do. There isn't anything automatic about arc welding. You need to put that metal where it belongs and learn to see the weld as it's going in. When you're done, inspect every weld you make. If what you did worked, do it again. If it didn't work, try something different. A smooth, uniform weld bead will come with practice, but you do want the sides of the weld to be tied in nicely to the base metal. If the sides aren't tied in, you may be moving too fast, jamming the rod into the puddle, or running too low of an amperage setting. Moving too slow will overheat the base metal. Long arcing will produce an inconsistent weld bead with excessive spatter. Everybody welds a little different, so watch other welders if you get the chance and develop a style and rhythm of your own. Practice with different types and sizes of rods, and remember, arc welding is about making one good weld bead at a time.